Hello, my name is Sunny Hansda, register number UR15 CS316, and today I am going to show you a C++ program for single linked list. As we can see here the question, implementation of the following operation in the singly linked list: insertion operation at the front of the list, at the back of the list, and at any position in the list, deletion of an element from the list, and display all the elements in the list. So here we can see this is our program. First of all, I have created a structure named node which is having two elements, data which is of data type integer, and a pointer variable as next which is having the data type as node, and also a pointer variable as start which is our starting point in the linked list. And after that I have declared a class named single list, and it's having members as public members. It's having a node of the pointer, create node integer, insert begin, insert pause, insert last, delete pause, and display. And inside the main program I have made the object out of the class as s1, and I have also declared start as null. And after that, inside the while loop I have displayed the messages as insert node at beginning, insert node at last, insert node at position, delete a particular node, display linked list, and after that I have also displayed the message as enter your choice. Taking the input from the user in the choice value, I have used a switch case, and so in case 1 I have inserting node at the beginning, and after that I have called the insert begin function with the help of object, and after that it will go from there to here, insert begin. So inside this we have a variable named value, and after that it will display the output message as enter the value to be inserted, and then the value will be taken in the variable value. And after that there is a star temp and star p which are the copies of structure that are created. And after that there is also temp which is inside temp we are also calling another function which is create node. So without creating node we can't enter any values inside the linked list, so it will call another function which is create node int value. So here create node with the parameter of the value it's going to call. So inside this create node again we have having star temp and star s which are the copies of the structure, and inside temp we have new struct node, and inside temp data we are going to store the value, and temp next will be equal to null. So after that the value will be stored in the temp and it will give the value. So if we will have start is equal to null, that means that if start value is 0 or we don't have anything in the start, then it will just simply put the temp value in the start and it will put start next is equal to null. So we only have one element stored in the linked list. So or if else, if it's not if it's having values, then it will just copy the starting value inside p and then temp value in start and then put start of next is equal to p. So it's a type of exchange, and it will exchange the values and make our values to be inserted at the first, and after that it will display the message as element inserted at the beginning. So after that in case 2 we have inserting node at the last, and it will again call the insert last function. So under our insert last function again we have value, into the value to be inserted, and value again it will create copies of the structure inside temp and star s, and again temp will call the create node function, and this time s is equal to start. So and we will run our loop, because we don't know how many um, elements are present in the loop. So we will proceed and transverse till s of next is not equal to null. When till s of s next is not equal to null, so after that s is equal to s of next, so it will just transverse through every element. So it will run when s of next is equal to null, it will exit the loop, and then temp of next is equal to null, it will put the value null, and s of next is equal to temp. So after this, the element which is inserted will be the last element in the linked list. And so like that we have inserting node state case based inserting node at the given position, and again we have here insert position function. So when we'll insert position, here we have here we can see that we have value pos and counter is equal to 0. Again we have entered the value to be inserted, and we will get the value from the user. Then we have star temp, star s, and star ptr, which are the copies of the structure. And again we are using temp is equal to create node value, and it will create a node in the linked list. And again then we have the output message as enter the position at which the node has to be inserted, and we'll get the position to which we will insert the node. For that we have used a variable I, and then again we have start is copied into s, and why we'll run a loop so that we can reach transverse till the element we are required to go. So while s is not equal to null, so it will run till s is equal to null. So s is equal to s of next, and for each jump we will increase the counter value by 1. And after that we have if position is equal to 1, then value of it's a nested if condition. So if position is 1, then again it will check if start is equal to null. So that means if start is having no value, then start is will equal to temp, and start of next is equal to null, and then we only have one member in the linked list. So if else pointer value will be equal to start, and then start is equal to temp, and then start of next is equal to pointer. So if POS is equal to 1, then we will have these conditions. If it's not, then if POS is greater than 1 and POS is less than equal to counter, so its value is greater than 1 but less than equal to counter, then we will also have s is equal to start. So we are copying the value of start in the s, and again we are running a loop because we know the upper and lower limit. That's why we are using a for loop here. So it will go from I is equal to 1 to I is less than pos, and will increment the value of I. So inside that we will store the value of s in pointer, and s is equal to s of next, and outside the loop we have pointer of next is equal to temp, and temp of next is equal to s. And if any of the conditions are not met, then we have the output message displayed as position out of range. And case 4 is delete a particular node, and s1 dot delete pos. So it will call the delete function, which is here for deleting the element in the linked list. Again we have the variable name as pos I and counter, which is equal to 0. And if we have start is equal to null, that means if our linked list is empty, then it will display the message as linked list is empty. And if it's not, then it will display the message as enter the position of the value to be deleted, and it will get the position of the value to be deleted. And then we are also making copies of the structure star s and star ptr, and again we are storing the value of start inside s, and if pos is equal to 1, then start is equal to s of next. And if it's not, then while s is not equal to null, so it will run the loop till s is equal to null, and for each iteration s is equal to s of next, and it will increment the counter by 1, and if the position value lies from 0 to counter, then we are having another loop. So before that we also have s is equal to start, which is storing the value of start in the s, and we'll run a for loop from I is equal to 1, I is less than wash, and I plus plus. So for each iteration ptr is equal to s and s is equal to s of next. So it will go till that element, before that element, and it will stop, and then it will delete that element, the required element. So for that we have ptr of next is equal to s of next, and if any of the conditions are not met, then position out of range will be displayed, and after that the element s, which is our element which is to be deleted, is deleted, and displayed the output message as element deleted. And at last we have case 5, display elements of the linked list, and it will call this display function. So it will go here in the program, it will go to the display function, and here we can see that we have created a copy of the structure in start temp, and here we have if condition, if start is equal to null. As we know, if our linked list is empty, then it will display the message as list is empty, and it will exit. So if it's not, then we are going to store the value of start inside temp, and display the elements in the list as elements of the list are, again we will run the loop, as we don't know how much elements are stored, so we are going to use the while loop when temp is not equal to null. So it will run till temp is equal to null, and will display the output as temp of next data, then temp is equal to temp. So for each iteration it will display the element, and it will jump till we are going to get temp of next temp is equal to null. So here we can see when temp is equal to temp next, so it will run, and it will display full on the elements present in the linked list, and we can see here in the program, insert node at the beginning, insert node at the last, node at the position, delete a particular node, display linked list. So if you want to insert a node in the beginning, enter the value to be inserted, 65, insert node. If you want to insert node at the last, so insert the value 43. Again, if you want to insert in the beginning, 234, and if you want to display the linked list, then we will have 234, which was inserted in the first, then we have 65, and then 43, because 43 was we had inserted in the last, so 43 is inserted at the last. So if you want to delete a particular node, enter the position of the value to be deleted. So if you want to delete, say, second, and if we will display after deleting, it will display 234 and 43. As we can see, 65, which was the second element, is deleted, and after 43 we have nothing, so we are having there null. So this is it. This is the program, C++ program for the implementation of singly linked list. Thank you for watching the video.